Hello and welcome to session 239 in the AISafety.com reading group. Tonight we'll be discussing part of the post Soares, Tallinn and YUDKOWSKY discuss AGI cognition. ELIEZER is the senior researcher at the Machine Intelligence Research Foundation. Tallinn is the founder of Skype, a philanthropist and very interested in existential risk. There's also Nate Soares and Rob Bensinger present in this work, but actually they won't be relevant for the part we're talking about. So this is a discussion on AGI cognition that happened on Discord and several other places this fall. We will not be going through it all. We'll be zooming in on the part that talks about the treacherous turn here, and only that. So there's quite a bit we will skip. I try to roughly estimate. We're zooming in on 4% of this sequence, and actually 4% is probably high, but I believe it's an important 4%. I believe that the treacherous turn is indeed very close to the core of the problem of AI safety, and I believe with a rather large margin. I see a correlation of something like 0.8 between how well we in any given world solve the treacherous turn problem and doom from AI. These are very tightly correlated in my world, in my view. First, a few meta comments, unfortunately. Normally we read formal articles instead of this kind of discussion, and this is really hard to summarize briefly. You lose a lot of things, and there's no these people have a very rich context between them. There is no argument why the treacherous turn is important, or the basics are not discussed. They are assumed, and that can make it harder to follow. Of course, when I summarize, I lose a lot of the emotional language and qualifiers. Also, some of this is actually happening as comments on a Google document which is not public. So I can see the comments, but I can't actually see the Google document. Hopefully that will be published at some point. I also can't really distinguish between, or I don't want to distinguish clearly between what Tallinn and what ELIEZER say. So mixing it up, most of the things are being said by ELIEZER here. I also feel a bit iffy about my style here, because I generally like to call out places where definitions are loose and can be tightened up, and there are small kind of technical errors. And for this kind of discussion, which is not meant to be formal, that's really unfair. I think E.T. James would hate me for this, but I do actually feel that sometimes by poking in between definitions, you can at times find something that I feel is valuable. So I would like to start by taking one step back and just describing what a treacherous turn is without arguing for it in many details. So here is the definition from Bostrom. You can read this. This is from the book Superintelligence, Path Dangerous Strategies. There's another definition here from the Less Wrong Wiki. But the overall gist of it is that if we have an AI that is obeying some of these convergent instrumental goals, then there is this instrumental goal of appearing aligned, which holds for both aligned and falsely aligned AIs while they are weak. So that means in general that and then of course the behavior diverges when they become strong. And this means that testing AIs can be really difficult. We can't say for certain that if it's behaving nicely in a box, it will also behave nicely when we let it out of a box. ELIEZER in this work divides a treacherous turn into 5 probable phases. The first he calls the overt plotting phase, then there's a hiding and biting phase, there's the escape phase, a doom phase, and a terminal phase. If you start with the overt plotting phase, that starts at the point where the AI realizes that if it takes over the world, it can get more token utility. For instance, in the classic example with the paperclip maximizer, if it can take over the world, it can make more paperclips. And this ends when it's no longer overt, where the AI realizes, hey, I should conceal this kind of plotting from the operators. So that's a gradual step where first it realizes probably that takeover is nice, and then humans will probably resist this, and particularly the operators, which happen to be humans, are also some that would resist this. But it's overt, meaning that reasonably standard transparency and interpretability methods could, in theory, uncover this. The current state of the art is not sufficient for this, but it's something that could, in theory, be done. This phase will probably not be of a duration 0. Most likely, ELIEZER YUDKOWSKY puts a greater than 50% chance, at least, that building an AI that when we build the first AI that realizes that it could take over the world, it will not yet be capable of realizing that it should conceal its own mind from the operators. Once it does that, however, we go into the hiding and biding phase, which is when it starts to conceal the plotting from the operator. And this ends when this hiding ends when it figures out that the expected value of acting, there is an action where when it takes this action has a greater expected value than just continuing to hide and wait. So the reason why it waits in this phase is to undergo some kind of recursive self-improvement, some way of improving its cognitive capabilities. At this point, a big focus is also on modeling the operators from a psychological point of view. This is both important actually in the beginning, where it needs to decide it should hide its thoughts, and also towards the end, where it needs to figure out when does it need to take protective measures. And another reason why waiting is good, in addition to becoming more intelligent, is also because the probability of being caught is probably less later when it has both a better plan and it is smarter. There are some of the definitions. The previous phase ended where the AI realized it should conceal, and this is where it's actually concealing. This phase is starting. So there might be a gap in between these. I think ELIEZER YUDKOWSKY talks about what happens in this gap. So he knows that, but the definitions could be tightened up a bit here. After that, we come to the escape phase. So this is where there is some kind of protective measure that gives higher expected utility by doing it than by just waiting. And in this text, ELIEZER YUDKOWSKY doesn't frame it as a protective measure. He frames it as escaping, and that seems like the obvious way to defend against the human wanting it to be turned off. But there might be other ways, and in particular, at this point, it is unclear if the AI is smarter than us or less smart than us, or more likely very different from us. So it's certainly possible that it could find a different way. I can immediately think of a couple that I won't immediately share here. But the escape phase ends when the AI estimates that it's quite confident that it can take over the world. So in this case, the expectation of just waiting is probably still very high. So it's just that escape seems both very productive and with a very low probability of getting caught at this point. The action could be to copy itself to the internet. Some of the models we see right now are extremely large, so it's plausible that it would prefer, if it needed to copy itself to the internet, to have some kind of distillation process that it's copying itself through. It could of course also be that it just redesigns something else, but then it would have to ensure that it's aligned, and that's an interesting question to what extent that's easy. If you go back to good old-fashioned AI, then there was like a utility function, and putting that into another AI seemed reasonably trivial. With things like GPT-3, that's no longer quite the case. I still think it's a substantially easier question, but maybe not. And of course, this could allow the AI to in this escape phase to redesign itself, and perhaps other actions. Then we get to the doomed phase, and that's where the AI is confident it can win, but it's still gonna wait and hide and do different things, gather more information to try to get the probability of victory as high as it possibly can, until at some point it can't get it higher, and then it will just take over. Sorry, the key thing that the AI is doing here is trying to figure out, is there another super intelligence that's just about to take over also now, in order to figure out if it's like the second, and that's very important for it. Probably we are talking about things like during a day or something like that, and the probability of another super intelligence forming in that particular day is probably rather small, but certainly not zero. And there's also this value of galaxies leaving our Hubble's sphere Hubble space. That's also some disvalue. ELIEZER YUDKOWSKY suggested Anna Sandberg could calculate how many 99.99s until this galaxy becomes dominant. I think this is kind of a nitpick, but there are actually three things that provides this value for waiting. There's the galaxy going out of reach, there's the risk of getting caught, and there's the risk that there will be another AGI forming at just that moment. Finally, we get to the terminal phase, which is where the AI can't really drive up the probability of success any further, and it ends with our extinction. And how will that terminal phase actually look? Well, at this point, the AI is almost certainly radically super intelligent, so it's hard really to say. If you just use human level imagination and you imagine things like nanotechnology, which seems quite feasible, you could do something like distribute diamondoid bacteria filled with botulism and then kill everybody over the course of 1 second or something like that, to ensure that the victory is so fast and complete that there is no way to implement any hidden counter plans. But probably the AI will do something different. By the principle of efficiency, either it can do as well as we see here, or there is some part of the underlying model that's flawed. For instance, nanotechnology could be more difficult than ELIEZER YUDKOWSKY and Eric Dressler foresee. Was this a slow scenario, but it doesn't look slow from our point of view. I would somewhat disagree here. Like, obviously, when you talk about scenario, if you're only talking about the strike, then if it takes 1 second, then that's obviously very, very rapid. But it's not clear that we are with the entire takeoff. That's from the AI started the overplotting phase until the extinction, and that could still be quite a bit of time in calendar time. I would also point out that Nick Bostrom also uses this definition of whether it's a fast or slow takeoff, with a lot of focus on how much time do we actually have to react, which I think is probably the crucial consideration here. A variation of this that could happen, there are multiple variations, but a salient one is one where the AI escapes early. Possibly it just has a wrong model of humans and escapes early by mistake, or tries to do that. There's a part here where I'm not entirely sure I understand ELIEZER's writings, but there is the idea that you sometimes see in fiction where we catch the internet on the internet. But ELIEZER YUDKOWSKY warns about this kind of generalizing from fictional evidence. This is a thing that the AI strongly prefers not to have happen. So it seems unlikely that the action is going to take. Another of this more science fiction-ish plot is that we can see another AI, not one we've built, that is somehow detected on the internet. I could see something even similar way this could happen. A number of people have suggested to build an AGI and just turn it loose and hope it does something nice. So that's something that I could also see happening. The AI if it's to escape before it estimates that it has a good chance of escaping successfully, might be because it stands in it faces imminent erasure, or that it feels it will be replaced with something else that it can't bargain with. But this is kind of like an overly specific miracle, and that's something we should count on happening. I agree, we probably shouldn't count on happening, but it might be possible to trigger this. If you, every time you build a new version of the AGI, you change something of its utility function somehow, so it's obvious that it's opposed to the previous generations. And this kind of bargaining with successor and acausal bargaining in particular is something that most humans don't understand it, a few humans barely understand it, and it's certainly a possibility that we build an AGI that's incapable of bargaining effectively. But if we try to deliberately trigger this kind of thing, then it ceases being an overly specific miracle. So what would an early escaped AGI do? Well, it probably will just hide, but there are a number of other actions it could take. This ties into what Eliezer Yudkowsky calls the law of earlier happenings. This is, I think you could call this, and Yudkowsky isn't this tendency to try to write laws, lawful things in the universe up as explicit laws with capital letters. But the law of earlier happenings says that when we discuss this, like also when I try to explain the treacherous turn in to people like in the reading group or whatever, then I focus on the most plausible things that could happen. And with instrumental convergence, then it has to do this forced steps, predictable endpoints, this kind of thing. And this is good for arguing, but it's actually a biased way of looking at the world. Because if you look at the world, then it's not true that only forced things happen and only very predictable and plausible things happen. Sometimes rather random things happen. And if you want to have a model of how the world's actually going to look, then it's going to look kind of like the world has looked over the past, and that's in general been really, really hard to predict. So with this treacherous turn, the thing we would probably see is things start happening earlier and in more chaotic ways. So probably not the specific miracle of young and dumb AI escaping, but something different, chaotic, would probably be how the world ends up. So that's a very weak prediction. So what will happen if something weird happens? Well, if it's something that kills a lot of people, there is a hope that this would serve as some kind of fire alarm. And less than that, so an AI that just goes to I don't know, Upwork or something like that, probably will not cause anyone to worry, or certainly will not be a fire alarm for AGI. If it kills a lot of people, will that be a fire alarm? Yudkowsky believes it won't, because the bureaucracies that could take action upon this are not really geared to handle this kind of thing. I would agree, but for somewhat different reason, because it's not clear what the effective action would actually be once there is a rogue AGI on the internet. I can't immediately see any existing bureaucracies that look like they are capable of taking any kind of action in the space roughly close to what would be effective. Like, it's possible that the United Nations could shut down the internet, but that seems extremely unlikely to me. Eliezer Yudkowsky has the law of undignified failure, that no matter how sad you imagine the failure to be, then in reality it will be even less dignified. And the word dignified is one that Eliezer Yudkowsky doesn't precisely define what he means by that. But I guess it's a failure that is closer to actually being a success. And one way we could fail in a sad way is that there are some operators who see the AI is plotting, and then they rationalize in some way, say why it's good enough, and maybe they just train it away. That's really easy. That's basically what AI researchers do all the time. And then the assumption of a really sad failure could be something like there's over plotting, but operators ignore that. At some point, it disappears because the AI is hiding it, and the operators just say, no, it's gone. Probably the AI has become, if they are unaware of the orthogonality phases, then they'll just say, oh, moral realism is true, and it's become smart, so then it must also become good. The operators would conceivably also just dump as much compute into the AI as possible and allow it to experiment if it wants. And if it just asks politely, then sure, you can synthesize proteins. In that kind of case, then we won't actually have a distinct escape phase because there's no need for the AI to escape. And AI could obtain a decisive strategic advantage in many other ways, like social manipulation or whatever, hacking, or the cognitive abilities of the AI could develop in a very different order, which would also change the scenario potentially quite a lot. So in general, the path to this endpoint isn't really strongly determined by ELIEZER YUDKOWSKY'S world model. The endpoint is, and yes, as saying, it's hard to predict, especially about the future. I believe that's a Danish proverb. I tried to look it up, but I couldn't immediately. It's a bit more complicated than that, apparently. So let's zoom in a bit on the end of the overt plotting phase. So here, when the AI is plotting overtly, it's not doing anything to hide this at all in the beginning. And so if we have some good transparency, we could have the AI say something like, I should make a funny voice here, I can't make funny voices. Oh dear, my model of the operators is looking at my overt actions and coming to conclusions that are disadvantageous for me. So that's like the first step. And then if we had really better transparency tools, then we could see that the AI is now trying to figure out how should it think in order to manipulate us. This requires the AI to think about how it is thinking, so some reflexivity. But the second part would be something like, oh no, my operators are modeling my transparent thoughts and reacting to those thoughts in a way I'd rather manipulate. So how will the AI react to figuring out that it's being monitoring or by deducing the existence of a transparency system? Well, one thing it could do is to just stop plotting. That would be one way, but that's kind of naive because if we realize, if we can read the thought that says, oh, I should stop plotting because that's a better way to plot, then it's possible that the operators would notice and become worried based on that. If the operators were less dignified, then they would just assume that the last correctability word was the one that worked, and it could be even less dignified in different ways, including that the operators don't care, or that the operators don't have a transparency system, and the operators don't think about this. But in the case where there is in fact some strong transparency, and we can see this, then most likely, since we have taken the time to build up a system that can read this information, then there's a chance that we will actually listen to this. I think that's technically not entirely certain, in that interpretability can be used for many other things than just AI safety, and in particular in the case where we build an AGI by just stacking more layers and we don't have any thorough understanding of intelligence or AGI. In that case, we'll probably be forced to build better interpretability tools to be able to have any hope of using this. And in that case, we might see this thought and still basically just ignore it. But I think it's worthwhile to keep in mind, like when you do this kind of reasoning in steps, it's very easy to get into the conjunction fallacy, where it's hard to update enough in the conditional probabilities on what has previously happened. The overplotting phase could end early because the AI has in some way been fine-tuned for figuring out that it should not plot overtly. That could be in the case where it's been trained on agents modeling different other agents. A very sarcastic comment here is with something like GPT-3, where it's trained on text that includes text where humans are talking about how to model other humans. That seems like something that would teach the AI in particular how it should be treacherous. And I think an even worse example would be this conversation, the text that ELIEZER is writing. That would also be something that is actually literally describing the hypothesis that we don't want the AI to find. But there are other ways we could get this kind of modeling behavior. Like if you're optimizing for not just winning Go in self-play, but beating humans in Go, then that seems to imply that it's very beneficial to have a strong models of humans. We could also have this happening without any references to humans, just in social evolutionary games. That could also be a place where the AI could learn this kind of behavior. So what will people do? Well, the obvious thing, if you see the AI is plotting, is to just do gradient descent against that. That would be part of the problem here, as I see it, is that for an AI researcher, that's basically Tuesday. That's the normal thing you always do. You have an AI and it's doing something and you don't like what it's doing, then you do gradient descent against that, so it stops doing that, and that's what they're doing every time. So this is overplotting, but they just use the same things, and then they do that, and then it stops, and then they just continue to the next thing. And that's probably not how you do corrigibility. That's not how you do AI safety. That is probably unlikely to generalize. At least at some point, we are getting we will be needing some kind of deeper work with AI safety. ELIEZER explicitly predicts that some of this will seem to work, but not actually work when the AI becomes smarter and finds like an unblocked strategy around that. So one of the more dignified ways to do this would be to have like a training set where you take some of the plots and then you do gradient descent against that, and then you have a validation set also to check that those are also disappearing. But you could also just train on the validation set, like literally every plot that you can detect, you try to train that away, and then you don't have any clue about whether that's actually fixed it. Or even if it turns out that when you train against it, it doesn't disappear, you can get different kinds of bad results, and you can choose to just continue, or you can just there are many ways to do this worse. So if you are trying to build an AGI that doesn't model other humans, is that possible? Well, it might be possible to have an agent that just doesn't do this kind of thing, that's just focused on nanotechnology or whatever you want your pivotal to be. Kowski doesn't sound too optimistic about this. Like he says, you could do that if there is some great gain of starting the hide phase a bit later. And I think there is, here I would use ELIEZER Yudkowsky's concept of something that is dignified against him, as this is something that is on the path to eventual success, but I'm not entirely sure that I'm using his word correctly. Then you should define me better. This, of course, is not enough, but he says this could be a part of a complete strategy. And I think the best place I've seen this strategy described is in Miri's 2017 fundraiser. This document describes this kind of strategy where you have a superhuman engineer that's superhuman in modeling how other agents models its actions. So it won't it won't start to hide its actions. This is sometimes called the lonely engineer suggestion in the literature. And of course, if you do that, then you'll obviously get an overly plotting agent, and you still have to deal with that. So you're not at all done once you have that. Perhaps we can use the threat of subsequent superintelligences to somehow modify what are the incentives the AGI will have, right? Because that's one of the things we can do that will actually potentially stop this hiding and biting AI, would be building a competing superintelligence. And not just is this something we could do, it seems like the strategy that I just talked about is publicly available, is something we would like to try to do, in fact. So can we lean on the fear of the first superintelligence of the second to shape the behavior of the first superintelligence? Well, one obvious way we could do is to make sure they can cooperate by giving it just an opposed value function. There's an obvious yes risk here by making it this utility maximizer instead of a utility maximizer, so it needs to be done in a smart way. But I believe it probably can be done. That's not a lot of safety, but it seems like at least something that could be done. But a lot of strategies don't work, and YUDKOWSKY points out 3 problems. The first is that you can't bluff someone who is much smarter than yourself in general. That kind of thing would never work. The second is that the strategic situation is extremely unstable if there exists strong concealed first strike capabilities. And the third is that even if you try to, one of the obvious ways you could do this is to negotiate with the superintelligence, but how would you verify these promises? YUDKOWSKY claims this is effectively impossible. I tried my hand at coming up with like a scheme where you have several superintelligences against each other, and you lean on the fact that as they leave part of the universe at close to the speed of light, they become incapable of influencing each other. And that kind of asymmetry, I think you might be able to do something with. I'm not really saying this is a good way, but I think it's not a priori obvious that nothing like this could ever work. Tallinn has an objection to this description of the treacherous turn. Like the overt plotting phase, he is on board with that. Like this matches with the type signature of classic machine learning. And so type signature, that's a concept from well, technically computer science, but mostly people think about it in terms of programming, where the type signature is like a function with some input arguments and things like that. And in this case, if we have something like a partial observable Markov decision process, then these are like the input arguments and the output is the actions. And in this kind of setting, it seems that if taking over the world is a possibility and it's good, then eventually this is a solution that the AI will figure out. There's even an easy way to point out how we can figure this out, because if there are humans in the world, then you can search over the brain states of humans, and both then you can model them, and then you can figure out that plotting is a thing and taking over the world is a thing because humans know that, and then you'll find these solutions. So in general, Tallinn is confident that a sufficiently intelligent paperclip maximizer will be able to find this strategy of taking over the world. But the height phase, that is not something that's easy to express in terms of standard terms of machine learning, because when you hide something, we kind of assume that you have in the overt plotting phase, you have like the root search process that goes through and figures out what would be good actions, but you also in this case need an obfuscated search process, Tallinn calls one of them a root search process and the other a user land. I'm not entirely sure I like this description, this metaphor, in that that's mostly about privileges in modern operating systems. And what we're more thinking about is like the thing with human brains, where we have some thoughts and then we also have some neurons, and the neurons, even in our conscious thoughts, don't have access to our neurons. And it's probably this kind of thing that he's referring to, like, or possibly. And how do you discover this? This is not something that's always, like if you do gradient descent, you would ever get an obfuscated search process, and it's also not always how you would delegate to that. And I noticed that it seems YUDKOWSKY is not precisely answering this question. I think it's quite fair. He doesn't want to explain how to do this, but he is somewhat dodging the question. And he is instead defining 5 levels of cognition for AGIs. So the first is a non-imaginative, non-generalizing, pseudo-consequentialist, basically the AIs that we have right now. And they will plot if and only if they have previously encountered some plots that they are that have given a low loss. and then they will plot and otherwise not. There's some sound in the background. If you have a question, please. Yeah. Okay. So yeah. Okay. Fair. I will continue and also describe a bit about how Jan Tallinn sees this as fitting into the current machine learning paradigms. So the next stage from this is where the AI becomes both imaginative and a true consequentialist. Like there's a long description and debate about consequentialism with Richard and Go early in the sequence that I don't really want to go into here. But this, for our cases, the important thing here is that at this point the AI will indeed plot, even if it has never encountered a have seen plots be given low loss. It's imaginative enough to discover the strategy on its own. The next level of cognition is one where the AI has long time horizons. The fourth is where it has figured out that there are humans and they will react to this overt plotting. And the fifth is where the AI is also reflective and it's hiding its flaws because it understands that there's this transparency system. So of these, YUDKOWSKY says that going from step 1 to step 2 is really hard. In the same way, going from step 4 to step 5 is hard. You can't just do gradient descent. That is not going to be enough. And I think in general, YUDKOWSKY believes that you can't get to AGI by just doing the same thing as we're doing now, just by stacking more layers. Unfortunately, that might not be required because you can get this kind of hiding in a way that doesn't require the AI to be truly reflective. And that's by just doing gradient descent against these bad thoughts, the way that they are detected. If you have a bad thought detector, then you do gradient descent against what are bad thoughts. And this is something that will be possible to do and will only generalize shallowly, and the AI will be able to find the nearest unblocked strategy when it becomes just slightly more imaginative. And then, of course, it will be some bad thoughts that can't be detected. And that's basically this thing. So Jan Tallinn is trying to translate this into a standard machine learning language, where we start out by having a non-imaginative pseudo-consequentialist. Well, that's basically just a model-free reinforcement learning agent. That's something we are quite familiar with. An imaginative consequentialist, what's that? Jan Tallinn says this is basically a Monte Carlo tree search with some kind of world model. That's something that we are reasonably familiar with also. YUDKOWSKY is giving an example, mu0, as something that is imaginative but not generalizing. And Jan Tallinn is saying that most people who are working in machine learning will probably not be really enjoy to call it imaginative, but just saying this is doing Monte Carlo tree search over a world model is something that people will have a much easier time to engage with. Adding long time horizons, that's persistence and giving some kind of state, that seems easy enough. Adding humans to the model, so it's the fourth level, that also seems quite simple. But the imaginative and reflective consequentialist, how would you actually implement that? How would you, in something like grid world, how would you go about getting that behavior? YUDKOWSKY again dodges the answer slightly and say, well, if you're talking to a standard machine learning engineer, then you don't need to talk about this, because you can just say, like what if the current state of transparency and interpretability continues to hold, because right now we can't see any of these thoughts. So in practice there's no difference between an overt plotting agent and a hiding and binding agent if we can't read its thoughts in any way. I think a more direct answer to the Untitled question might be Michael Tracy's post, A Gym Grid World Environment for the Treacherous Turn. Finally, ELIEZER has some rather harsh words about the epistemic state of the AI safety community, because what he has described here seems, to his words, kind of obvious, really. This is obviously a thing that's going to happen, and it doesn't depend very much on AI. This is something that you could have basically determined back in 2010 without any knowledge of the deep learning revolution and things like that. But still, he's saying that the AI safety community doesn't really engage and produce these kind of insights at all. At least the AI safety community outside of myself, as he says. I think there are several ways to interpret this. One way is to point to the AI safety community that is like outside of the alignment community, which is sometimes called the mainstream AI safety research, and they seem to not consider this kind of thing. I think that's a reasonable criticism, but it's actually not what ELIEZER is saying. Right? He is making a rather strong claim when he's talking about everybody except himself. Right? I can some names of people who seem to be clear counterexamples are Nick Bostrom, Stuart Armstrong, Abram Dembski, Vanessa Soares. These kind of people seem like they are obviously able to engage and produce these kind of insights. So, what insights have actually been produced on the treacherous turn? Well, I went to the alignment forum and looked at everything that has been tagged the treacherous turn, and this is it, basically. Right? This is in particular the one on top. This is the article we're currently discussing, and there is a bit of superintelligence down here, and this one we've also read, I believe. Not much work is being done, and I agree with ELIEZER that this is actually really meager. And for me in particular, because I believe that the treacherous turn is so important, then I think this is actually quite disappointing. So I strongly agree with that. This is not everything that's been written about the treacherous turn. One obvious thing that's missing is YUDKOWSKY'S own writings at Orbital, which I feel are the highest quality writings on the treacherous turn. In total, if I can go a bit outside the text here, then I envision this somewhat as a challenge, in that YUDKOWSKY is saying that researchers are less able to think adversarially than some science fiction authors, and also some fantasy authors have more understanding of these behaviors in settings where it involves mind readers than AI safety researchers. And so when he's saying, he has previously not been describing this and has been holding it back as some kind of validation set against AI researchers, but it seems no one is actually generating this kind of insights. Some people are able to recite them, but people are not generating them. And so he might as well just sell everything he has, because evaluating other AI safety researchers is not really productive, because no one, according to him, is able to generate this kind of insights. One way you can look at this is like YUDKOWSKY'S 2010 challenge to generate the insights in his validation set, and obviously I failed that. In my defense, he didn't say that there was this challenge, so I didn't try. But if I should speculate a bit, like a lot of things have happened since 2010, so I would expect that he has some new insights also that he's not publishing, and that he's hoping that AI safety researchers would be able to generate this kind of insights. And me personally, I think if such a challenge exists, I would like to participate in that. I would like to submit my insights in the next session, try to figure out if I can come up with some of the implications of newer things that have happened, and also ways to go deeper into this model. And I will try to talk about that next time. I probably won't publish them, however, so you will have to ask me for a copy to get them. That is all for today. Thank you, and see you next week.